Bright Duty. Every student matters.
Moving on from the previous reactions, the fifth type of reactions after combination, exothermic, decomposition and endothermic reactions is the displacement reaction. It is different from the previously discussed reactions as it has its own properties. You'll see as we go. So in a compound where one single element and one compound are reacting and a more reactive element displaces an element from its compound, then it is called as a displacement reaction. So here the element A is able to push out B from its own compound, it becomes out and A combines with the C to form a compound, then it is called as a displacement reaction. We can understand this with example. If we put lead in copper chloride, which is green in color, then PbCl2 plus Cu is formed. So copper is replaced from its own chloride by lead and it comes out as an element, and the green color is also lost. A new colorless compound is obtained, which is actually lead chloride. Now another activity which is very important from examination point of view is this. The activity asks you to make an aqueous solution of copper sulfate and then put an iron nail in it. When we dip an iron nail in the solution and we leave it for a couple of hours, what we see is that the blue color starts to disappear and a colorless solution is obtained. And on the iron nail there is red-brown deposition. Why does this happen? This happens because when the iron in the nail reacts with the copper sulfate, a new solution of FeSO4 is formed and copper is kicked out. The copper that is kicked out starts depositing on the iron nail in red-brown substance, and you can see this clearly because the blue color is lost and now it is green. And the iron which was initially had a greyish color now turns red-brown. So a lot of questions can be asked from this from examination perspective. They can ask you why is the color of copper sulfate lost, or they can ask you that in a blue solution an iron nail was dipped, identify the solution if the color has changed. So they can ask you to identify the elements of copper sulfate or of iron. They can ask you what will be the observation. In the observation you will tell that iron, you can see that copper will be deposited on the iron nail and the blue color will slowly wash away. Take about 10 ml saturated copper sulfate solution in test tube A and test tube B and place the test tube in the test tube stand. Remove the test tube B and clamp it onto the iron stand. Once it is clamped, take the iron nails and clean them thoroughly by rubbing the sandpaper so that the silver grey surface of iron appears. So if there is any rust on the surface, you remove it by rubbing it on the sandpaper. Once the nails appear clean, they are ready for the activity. Tie one nail with a thread and immerse it in the copper sulfate solution in the test tube B. Keep the second nail separately for comparison. So the other nail and the other solution is simply for comparison. Now we leave this apparatus here undisturbed for about 20 minutes. What we will see after 20 minutes is that there is a change in the color of the solution. Take out the nail and you will see that the change in the color of the nail as well as the solution. So when we compare the first nail to the second nail, we realize that there is a difference. There is also a difference in the change in the color of the test tube A and test tube B. You observe that the nail after experiment is coated with reddish brown deposit. This deposit is of the metal which was displaced from the copper sulfate solution, that is deposit of copper. The color of the solution test tube B is very light as compared to copper sulfate in test tube A. This change in color is due to the reduction of copper ions which get displaced by more active metals of iron. So the more active metal iron displaces the copper from its solution, and that displaced copper ions deposit around the nail. So CuSO4 plus Fe results in the formation of FeSO4 plus Cu as Cu gets displaced from its compound by iron, as it is a more reactive metal. So this was a classic example of displacement reaction. You will also be able to observe this change very easily based on the color of the nail as well as the solution, and that is why this activity is often used to understand displacement reaction. So all this is part of displacement reaction. But you can see here that copper is being replaced by iron. Can iron replace copper? But can copper replace iron? So to understand which element will be replaced and which element will replace, we need to understand something called as the reactivity series. Here you can see it's a list of elements, and the most reactive element is on the top and the least reactive element is on the bottom. An element which is more reactive, which is above in the reactivity series, will be able to displace the elements below it. It starts with potassium. Potassium is highly reactive, so reactive that it is dipped in kerosene and kept in labs, because it reacts with oxygen, it reacts with water and forms new compounds. Next is sodium. Next is calcium, magnesium, aluminium, zinc, iron, tin, lead, copper, silver, gold and platinum. So these are the list of elements in reactivity order, this being the most reactive and this being the least reactive. So calcium, for example, calcium can replace magnesium, aluminium, zinc, but aluminium cannot replace calcium. That won't be possible. So as we go down the series, the elements are less reactive, at the top more reactive. We also put hydrogen here, even though it is a non-metal, because hydrogen also combines sometimes and to form substances like HCl, H2SO4. So it is also added in the series to see its location. Based on the reactivity series, elements will combine. So if I give you zinc sulfate and I give you copper, there will be no reaction. There can be a question that if we add these two elements, will there be copper sulfate, which a blue substance obtained? No, that will not happen because zinc is higher up in the reactivity series than copper. So copper will not be able to replace zinc. This type of reaction is called as displacement reaction, where a more reactive substance displaces a lesser reactive substance from its compound. Sometimes two displacements takes place together, then it is called as double displacement reaction. This reaction happens when two compounds exchange their ions. The B here and the D here are ions. So the compounds exchange them. New compounds will be AD plus CB. They have exchanged their ions. In this case, it is called as double displacement reaction. Examples of double displacement can be sodium sulfate when added with barium chloride forms barium chloride, barium sulfate plus sodium chloride. So you can see this is a white colored precipitate that will settle down, and you can easily observe that this reaction has occurred. Take a clean test tube A and pour in it 5 ml of sodium sulfate solution. Take a clean test tube B and pour in it 5 ml of barium chloride. Put the contents of test tube A in the test tube B and make your observation. So when we mix both these contents, what you will see is that a milkiness appears and there is a white colored precipitate being formed. The white colored precipitate is due to the formation of insoluble barium sulfate. So what reaction happens here is that Na2SO4 reacts with barium chloride and there is an exchange of ion, because of which water soluble NaCl is formed and the precipitate of barium sulfate settles at the bottom. So in this reaction there is a double displacement happening, where there is an exchange of ions between two chemicals, and we can see it with the formation of the white PPT of barium sulfate. Another example that we also discussed before is lead nitrate reacting with potassium iodide. So here you can see that this is a PPT, this is a yellow color precipitate, And here this was a white colored precipitate. So most displacement reactions have, many displacement reactions have precipitate formation because of this new compound that is being formed by the exchange of ion. So far in this part we have discussed that there are types of chemical reactions, 6 types to be majorly. First is combination reaction. In combination reaction, substances combine to form one compound. Second, exothermic reaction where heat is released. Third, decomposition reaction where a complex compound breaks down in presence of energy. Fourth, endothermic reaction where energy is taken in, absorbed. Fifth, displacement reaction, more reactive metal displaces less reactive metal from its salt solution. And last, double displacement reaction where there is an exchange of ions. So that is all for the types of reaction.